Welcome back, folks. In today's class, I'll continue talking about from where we left in the last session, and we will talk about the isolated system, and we were talking about mechanical energy in that. Let's do a question on the mechanical energy for an isolated system. So, a pole vaulter with the mass of 56 kg tries to convert the kinetic energy of her approach into the height. What is the maximum height she can expect to attain if she approach with the speed of 8 meters per second? So this is the pole vaulter who has a pole in her hand, and her mass is 56 kgs, and then she attains a speed of 8 meters per second. 8 meters per second. Assume the center of mass of the vaulter is initially 0.850 meters above the ground. So center of mass, you can put it as the potential energy in this case. So it's basically telling you where the whole mass of her body is concentrated. So in physics, there is a concept of center of mass where it says that at one particular location, the whole of the mass of the body is concentrated. So basically, if we have to, we don't need to get into the center of mass at this level of physics, but I'll just want to tell you this is mainly about that we are trying to find the potential energy from the ground. That's what it is used for. We're gonna find out the mechanical energy. Mechanical energy will be equal to potential energy plus kinetic energy. Potential energy again mgh plus half mv square. That's what we're gonna do in this scenario. And then mass is 56 multiplied by 9.81. Again, I don't need to worry about the negative sign in this one. Plus oops multiplied by 0.8500850 plus half times mass is 56 times her velocity is 8 square. So if I were to do the calculations on this now, so 8 square is 64. 64 times 56 divided by 2, which is 1792. And then on the other side, it's 56 multiplied by 9.81 multiplied by 0.850, which is 466.956. And then this number plus 1792, that comes across as 2258.956. So that's the total mechanical energy which she will attain. And then with respect to the ground, so describe her change in energy that occurs when the vaulter starts running and she reaches to a highest point of her jump. So again, she is running in the forward direction, so she wanted to take a leap, and she leaps in the upward direction. So obviously I can say the whole of her mechanical energy will convert into potential energy. So that's what's going to happen in this case. So again, mechanical energy is constant. Mechanical energy is equal to potential plus kinetic energy. On top, kinetic energy is zero. She's not moving, that's why she's on top. So this will be zero. Everything gets converted into the potential energy mgh, and this is 2258.956. And then I can find the height from there. Describe the energy change. Actually, energy change that occurs, Walter reaches the highest point of the jump. We don't need to, but I'm still finding it. So might as well as I started. It just says that how much the energy change is there. So it's the same amount of energy change, whatever the mechanical energy is. And now 56 multiplied by 9.81 times it by height, and then 2258.956, and then this number divided by 56. Oops, I need to this number divided by 56 and then divided by 9.81, that comes across as 4.11 meters as the height gained by the uh, uh, I mean that will be the height gained by the pole vaulter. And yeah, and the energy change, there is no energy change. Total mechanical energy remains same, only changes that the kinetic energy will convert into the potential energy. Now everything is in the form of potential energy. Now, so that was it for the mechanical energy of the isolated system. Now I'm going to talk about another topic, that is the concept of power. So power, what is power? Power is the energy per unit time. That's what is power. So let's say if I'm running, by running 2 kilometer, for 2 hours, shall I say, for 2 hours, I end up spending 300 joules of energy. Just a random number I'm taking. So I wanted to find out the power, how much power did I spend? So power will be equal to, as I said, energy spent per unit time. So this 300 joules I end up spending by running 2 hours or jogging for 2 hours. So power will be equal to the energy, which is 300. Time has to be in seconds. So that will be equal to 2 hours means 2 times 60, which is 120 minutes. So then I have to convert it into seconds also. So multiplied by another 60. So it will come out to be 60 times 60 is 3600 multiplied by 2. So I'll do the calculation, multiplied by 2, 7200, and then the number will come across as 300 divided by 7200. That will be equal to 0.0416. And the units of the power is watt. It is WATT. Watt was the scientist who first talked about the power, so the units are for his name, like the force units belongs to Newton. Okay, so that's what power is, energy per unit time. Another concept is efficiency. It is denoted by this symbol. This is also called eta, and you can write efficiency EFFICIENCY too. So efficiency is equal to output upon input. So if, let's say, there is a motor and this motor is running, and then this motor is to run the motor, I have to connect it to electricity, and power is being supplied to this one, or I can say electricity is being supplied to this one, and then this motor is used to lift the water to a certain height. So let's say the output of this power is 30 joules. Input power is 60 joules. So what is the efficiency? So efficiency will be 30 divided by 60, that is 0.5. And then I can convert it into the percentage. To convert it into percentage, I have to multiply this by 100. So that will be 50% efficient this machine is. So that was the concept of efficiency. Now, based on this, I just want to tell you we can get the power from the potential energy also. So let's say if we are given the potential energy, the formula for the potential energy is mgh, and uh, if I divide this by time, that will also be power, because power is, as I said, energy. Whether we talk about potential, kinetic, they are just the form of energies, but they belong to the larger group, that is energy. So whatever form of energy is, if you divide by time, you're going to get the power output. So let's say if you see a very interesting concept here, height divided by time. Height divided by time means displacement. Height is what? Displacement in vertical direction. So displacement divided by time, if I see it carefully, that converts into the velocity, and then mgv. So what I'm trying to say here is, if you are given the velocity and you are not given the power, you can still find out the power by using this formula. So potential, now the power is equal to mgv.